believe that we will get a new insight about technology. Yeah, and okay, thank you. First of all, for joining this special presentation on trends in technology in Indonesia and Philippines. Especially this afternoon, we are going to discuss about transportation and Lean Six Sigma. Yeah, I think everyone will be like curious about that topic because recently that is more critical and more interesting that we will get a new insight from all the speakers in this afternoon. So this webinar actually is organized by the Faculty of Engineering and International Office, Universitas Tunas Pembangunan, in collaboration with College of Engineering Training Department and Office of International and Domestic Institutional Linkage, NEOS, Philippines. The webinar will be divided into several parts. First of all, it will be start by singing the national anthem of Indonesia and Philippines, and then followed by the opening remark, inspirational message, and then it is the main session. And at the end of the session, there will be a Q&A session. Okay, so before going to the main part, let's singing of our national anthem, Indonesia Raya from Indonesia, and Lupang Hinirang from Philippines. Okay, the ICT house, please play the songs. The ICT house, are you ready for the song? Okay, please up the voice. No voice at all. Okay, next, the national anthem from Philippines. The ICT house, please play the songs.
Ang pambansang awit ng Pilipinas.
Okay, finish. Okay, for the next part is opening remark of this webinar. Without further ado, I would like to invite the Rector of Universitas Tunas Pembangunan, Professor Dr. Insinyur Tresna Priana Sumardi. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Salam sehat. Very good afternoon, distinguished guests and leaders from news and the speakers, the Dean of the Faculty of Engineering, UTP, and the study program head in UTP, in engineering, civil engineering and architecture. And dear participant, it is an honor for me to open this webinar, and I would like to use my presentation to start the Okay, thank you very much. Everybody can see the capstone?
Yes.
Yes, it is clear?
Yes, clear enough.
Okay. Okay, thank you very much. This is a short note from me that I try to cover all the topics of the speakers will be presented here by Dr. Budi Yulianto, and the second speaker, Engineer Salvador Aloria, PhD, and the next engineer, Rick Donald Sai Manson. Dr. Budi Yulianto come from the UNS, ya? Betul Pak? Universitas
11 Maret,
Surakarta. So it is not far from Universitas 11 Maret, is not far from the UTP. It is our maybe it is old brother of the UTP, because the second rector who established the foundation of the Tunas Pembangunan and then make University of Tunas Pembangunan. So the second rector of UNS is Dr. Prakoso. Is that correct? And then also thanks to engineer Gina Lorenzo as a moderator. And very important, I would like to convey my gratitude and appreciation to engineer Feliciana B. Jacoba, educational doctors, SUC President Third News. Welcome, Mrs. Feliciana. Thank you very much for your participation in the webinar between Indonesia and Philippines. And also to Ati Eric G. Claudio, Head Office of International and Domestic Institutional Linkages, News. And ladies and gentlemen, this is I try to blend it all. The topic will be presented in this webinar with the smart city and society and digital transformation in new normal era. And global trends in engineering. Yeah, as the first information for you that Indonesia in figures, we have 270 million people. And then we have 5,000 kilometers span of the country from the west to east, and so many islands with 17,000 islands. And our economic capacity and before the COVID-19, that's more than $1 trillion GDP country. And then more than 4,000 income per capita per year. I think all now is a little bit degrade because the pandemic COVID-19. And more than 50% of Indonesian people live in the cities, and will be 67%. The people of Indonesia will be live in the cities in 2035. I try to, because it's okay. I would like also to deliver my message or short notes here that amenity and people well-being nowadays is very important. Yeah. So to provide this goal or this achievement of the people all over the world, that we have to create for a city. Yeah, as long as we can manage housing, mobility, energy, and environment for the people, so we will achieve the condition of smart and sustainable environment. So the people well-being and flora and fauna well protected for an amenity will be achieved by the people all over the world. So I think that these situations facing the COVID-19 pandemic it is a reflection of that conflict between the people and development and the flora and fauna not so well protected for an amenity. So it will be, I think, that the trend of engineering to support the global agenda that is a sustainable development goals. The ecosystem complexity, yeah, you see here that in this case, of course, for the well or thoughtful thinking about the ecosystem, we must organize, we must analyze very big data and information. So it is no other choice that the digital transformation nowadays, especially in the condition of COVID-19, the digital transformation is very important. And in other sectors, Industry 4.0 or the Industry Revolution 4.0 and Society 5.0 concept must be implemented very well in the next future. So it is a trend of the engineering nowadays is the Industry 4.0, smart cities and societies 5.0. So this is the visualization of the condition nowadays. That's the development of the cities or the development of the societies is very, very human-centrist. And as a matter of fact, the ecology or the ecosystem is natural in facing to the animals, to the flora, fauna, and also to the humans. It is a very important note for us to be thoughtful in the future step to overcome the problem we're facing nowadays. Pandemic COVID-19, as a matter of fact, is a natural process, is a natural phenomena, is a natural phenomena. Because the development of a country or a development of the globe, of the worldwide development, is a human-centrist approach. So the COVID-19 maybe more or less is our mistake how to treat the development to achieve the amenity and the harmony of the environment. So I think it is a note for engineering, trend in engineering to overcome all this problem. So I think webinar trends in engineering in Indonesia and Philippines, it is a smart and thoughtful topics. Thank you to Dr. Joko Setiowarno and substitute by Dr. Budi Julianto, who will talk about the implementation of smart public transportation. Of course, it's related with the smart energy, bicycle, and so on and so forth. Transportation smart infrastructure, for example, pedestrian. And thanks to engineer Salvador Aloria, PhD, who will talk about professional probity. It is very important to give the concrete role of the engineer to the downstream or market and to create improvement in research culture of engineer for their innovation And thanks to engineer Rick Donald Sai Manson, who will talk about Lean Six Sigma. And thanks to the moderator, engineer Gina Lorenzo. And I would like to deliver also that's to create an amenity, an harmony of the environment. Our government create 100 smart cities for Indonesia in the near future. And here I present that the government of the province of Central Java conduct what we call an amenity for the city and community project. We call in Central Java as Joglo Semar. Joglo Semar is an abbreviation of the 3 sister cities in Central Java. The first is Yogyakarta. It is very well-known tourism city in Indonesia. The second one after Bali. And then Solo, where I'm now live, is also the old city in Central Java and a heritage city and a tourism city as well. And then the third, this is Solo. You can see the photography here is in Solo. Solo is called also for the old name is Surakarta. Yeah, this is the pedestrian of the Slamet Riyadi Boulevard, the main boulevard in Surakarta. And this is the Malioboro Boulevard in Yogyakarta. It is the very crowded tourism area in Yogyakarta. And the next, this is the Juanda Boulevard in Semarang. I would like just also an information for all of you. We wish you all one day could visit Joglo Semar and wish you all an enjoyable webinar. And we wish God bless us and the COVID-19 pandemic will be gone in the near future, and we wish to back to the new normal with the life, with the new protocols, and comply with the protocol, worldwide protocol from the WHO, and so on and so forth. Thank you very much. Wish you enjoyable webinar. Gracia. Thank you. I back the time to moderator. Thank you very much, Mrs. Dia.
Okay, thank you very much, Prof. Tresna Priyana, for the great opening remark and slightly about today's topic. So I would like to invite Engineer Feliciana Jacoba, the President of NEOS, to give inspirational message. Okay, Engineer Feliciana, the time is yours. Okay, the ICT host, please help Engineer Feliciana to
Mute kali, sorry.
So, do you hear me now?
Yes.
Okay.
Yes.
Thank you very much, Miss Dia, to Professor Dr. Tresna Priana Sumardi. Good afternoon, Director of our partner university in Indonesia, Universitas Tunas Pembangunan, Surakarta, and other Indonesian officials. Good afternoon. The NUST Vice Presidents and other officials who are here, Dr. Attorney Eric Claudio and Dr. Janil Peria, our training director. Our Dr. Claudio is our director for the Office of International and Domestic Institutional Linkages. And of course, our director for training is Dr. Janil Peria. And most especially to our distinguished speakers and resource persons. And of course, our participants from all over the world. Good afternoon. Selamat sore.
Selamat sore.
Selamat sore.
Hello. It is truly gladdening and encouraging to know that as an important sector and one of the backbones of the industry around the world, our engineers are gathered here together in this webinar to talk and learn about current trends in the fields of engineering, especially nowadays that everyone must prepare our respective institutions and agencies for the new normal, as we have the saying, forewarned is forearmed. Every time we conduct training or webinar like this, we see to it that our participants will really benefit and enjoy in attending this activity. And as the university promotes high academic standard, research and extension integrity, it is engrossed in developing human resources into a more productive and ethical world leaders and citizens. Our dear participants, in this age and era of advanced technology, in the midst of COVID-19 pandemic, where the entire world lives in uncertain and turbulent times, we, the engineers, must be certain in our research and undertakings. Construction, transportation, energy and electrical power, manufacturing, computer and information technology, Lean Six Sigma, among others, because the world's technology advancement towards Industry 4.0 and Society 5.0 also depend on all of us. My dear friends, I know that we will learn a lot from our speakers who will be properly introduced later. Thank you very much, our dear resource speakers, for sharing your time and expertise with us. Let us listen vividly and participate actively in this webinar. I also would like to congratulate and express my appreciation to our training department, particularly the training director, Dr. Peria, our international and domestic institutional linkages office, and the College of Engineering, and all our coordinators, our partner, Universitas Tunas Pembangunan Surakarta. Terima kasih. May this be a good start of our friendship, and we are looking forward to a more partnerships with you. Thank you and God bless everyone.
Thank you very much.
Okay, thank you very much, Engineer Feliciana. Without further ado, I would also invite the head Office of International and Domestic Institutional Linkage, NEOS, Mr. Ati Eric, to give inspirational message. Okay, Mr. Ati, the time is yours.
Yeah, teka lang. Why? Ano ba yan? Salita lang si Eric sandali.
Okay, that's it. Do you hear me now?
Yes.
Okay. Good afternoon, everyone. From the
Afternoon.
Philippines to the entire world. Magandang hapon. Especially, I would like to thank the Rector of Universitas, Tunas, Pembangunan, Surakarta, Professor Dr. Tresna Priyana Sumardi. Good afternoon, sir.
Yeah, nice to meet you.
Yes, sir. And of course, to our dear President of Nueva Ecija University of Science and Technology, Philippines, Engineer Feliciana P. Jacoba. Good afternoon, ma'am. To all the participants of this international webinar series 2020, to the organizers of these two institutions of higher learning, good afternoon. With a deep sense of appreciation and pride, I wish to greet the International Webinar Series 2020 in this time of restraint from physical movement and contact brought about by the global pandemic of the virus COVID-19. This webinar is a bright ray in the dim atmosphere of world education and learning processes. Subordinated perhaps to the loss of multiple lives, and stalled economy is the problem of education. It is admittedly this institution of learning that bears the brunt of our world problem. Gladly, however, international webinar of this kind came into fore and provides the process and methods of education by way of online seminar through the internet. The gap posed by the worldwide calamity is in great measure bridged by an activity like this webinar. Our very own Nueva Ecija University of Science and Technology in this central plain of Luzon in the Philippines is sincerely gratified to be part of this international webinar series 2020. Furthermore, in collaboration with the Universitas Tunas Pembangunan Surakarta, Indonesia Faculty of Engineering and International Affairs Office, with the Nueva Ecija University of Science and Technology Training Department, College of Engineering, and the Office of the International and Domestic Institutional Linkages, will tackle trends in engineering in Indonesia and Philippines. The presence of this online seminar certainly makes our collaboration with foreign university tenable. The exchange of educational inputs from two institutions of learning is in more ways mutually beneficial. In all candor and humility, as the humble director of our university's Office of International and Domestic Institutional Linkages, wherein the basic load of utilizing the process falls in particular, and our university in general, I honestly have my hats off to this International Webinar Series 2020 for an admirable job. Once again, good afternoon, everyone.
Okay, thank you very much, Mr. Ati, for the inspirational message. Without further ado, we go to the main session of today's webinar that will be handled by Engineer Gina Lorenzo as a moderator. Okay, hello, Engineer Gina. Hello, Engineer Gina. Are you ready to handle the discussion?
Hello, Miss Dia.
Okay,
Thank you so
hello,
much.
good afternoon. Okay,
Yeah.
so I'll give the session to you to handle the discussion for today's webinar. Okay, you can
Yes.
start right now. Thank you.
So much. Okay. So once again, good afternoon, everyone. Good afternoon, participants from Indonesia, Philippines, Malaysia, Singapore, Timor-Leste, India, Saudi Arabia, and Uganda. Warmest greetings also to the dynamic leaders of both partner universities, the President of NEUST Philippines, Dr. Feliciana Jacoba, and Director of UTP Indonesia, Surakarta, Indonesia, Dr. Desna Priana Somardi. Of course, the administrators and coordinators of both partner universities, and of course, the students from different universities, different countries of the world. Welcome to the international webinar series of 2020 entitled Trends on Engineering in Indonesia and Philippines. I am your moderator, Tina Lorenzo from the College of Engineering, Mechanical Engineering Department, Nueva Ecija, University of Science and Technology, Philippines. We have three dynamic speakers for today's webinar. We'll talk on three important topics that are needed in the academe, industry, and our community as well. So allow me to introduce our first speaker for today's webinar. We'll talk about the role of bicycles as new wheel of urban transport and how it can be integrated into our city's urban transport systems. This topic is crucial in the current pandemic since COVID-19 is keeping most commuters away from public transport. Whereby cycling has quickly emerged as a safe and convenient alternative, and it is much easier to comply with social distancing guidelines. This will encourage our engineers to mull over new ideas on transportation design and systems that will implement the use of bicycle on urban roads. Our speaker is a lecturer and a transportation expert from the Department of Civil Engineering, Universitas Negeri Sebelas Maret, Surakarta in Indonesia. He obtained his Master's of Engineering on Highway Management and Engineering at the University of Birmingham, and he obtained his Doctor of Transport Engineering from University of Newcastle. He had published more than 29 researches about transportation management on international referee journals. He will be speaking for us for 20 minutes, so write down your questions, which he will answer on the Q&A portion of this webinar. And for your questions, please access our chat box. And finally, ladies and gentlemen, we are honored to welcome the pride of Universitas Negeri Sebelas Maret, Surakarta, Dr. Budi Yulianto.
Thank you very much, Ms. Gina Rejo. Good afternoon, all participants. Greeting from the Surakarta city in bright sunny condition today. My name is Budi Yulianto from Universitas Maret. I replaced the Dr. Joko for the presentation today. For the next 20 minutes, I will share the experience in the development of public transportation in the Surakarta city. And this is not a rocket science presentation, but it is very challenging effort to provide the public transport in Solo City to make the Solo City livable. Can I have the presentation, please? Yep. Okay, next. Next. So this is the transport paradox that transportation is unique as the only development actor that worsen when the economy improve. While the sanitation, health, education, employment tend to increase through the economic development, the traffic trend to worsen with high level of congestion, accident, pollution, etc. This raises the problem of urban transportation that affect the level of life feasibility. Next. There are two concepts in dealing with the transportation problem. The first is the capacity concept. This is the conventional concept. This concept is based on the provision of transport infrastructure. The cities in countries with a high number of motorized vehicles sacrifice a large portion of city space on highway infrastructure, etc., to accommodate the traffic movement and also the parking to accommodate the vehicle. The capacity concept is always to widen the road, to make an elevated road, to build tall, to build flyover, to build underpass, to provide the accessibility to motorcycle, car, and automobile. And the level of service measured by volume and divided the capacity. Can you go back again, please? The concept of capacity is the level of service is volume divided by capacity. In order to improve the level of service, therefore, the capacity must be enlarged. And this is, you can see from the picture that this is one example in Pancoran in Jakarta in 90s, where the traffic is very low. And then 45 years later, the traffic is really, really dense. Even they already built the toll, they built the flyover, underpass, and etc. And based on this experience, that this concept of capacity proved not to solve the traffic problem. Next. The second concept is sustainable transport. This concept control demand transportation. There are 4 ways to do the sustainable transport concept, namely traffic demand management, traffic management, public transport, and non-motorized transport. In general, this concept invites the community to use mass public transportation to reduce the traffic density. As you can see on the right picture, show that if the people, the community use a car, for example, in this case, 50 people use the car, it will require a larger road area than only one bus, which can accommodate just 5 community. So the idea, the sustainable concept, is referred to the broad subject of transport that is sustainable in the sense of social, environment, and climate impact. They to manage the demand rather than provide the supply, provide the infrastructure. And the next, according to the GIZ guideline, that there are 10 principles for the sustainable urban transport. They work one and each other, integrated one each other. For example, one is the planning dense and human scale cities. This is related with the planning of land use, developing transit-oriented cities, optimizing road network, implementing traffic transport, public transport, encouraging walking and cycling, controlling vehicle use, managing parking, promoting clean vehicle, communication, and intelligent transportation. This is 10 principles how to apply this sustainable urban transport. Next. According to Professor Fuchik, the selection of mass public transportation type is divided into 3 categories based on right of ways, namely A, B, C. The lowest right of way is C. This is, for example, like a regular bus where it lanes or it track, it's mixed with other vehicle. So the performance of the public transport depend on the traffic conditions because it is mixed, and the public transport do not have exclusive lane. While for the B and A have a special lane or track, so the performance is much better than the right of way C. For the B, it consists of a BRT, bus rapid transit, based on the highway, and LRT, light rapid transit, based on the railway. On the highest rank of way is metro. This is very, very exclusive. So based on the rank of way, we can see if the investment cost is higher, so there and also the system performance in terms of speed, reliability, capacity, image is better. So it will goes to the metro. The lowest one is the bus. Next. So this is the following picture illustrates the development of public transport process in the West Midlands, United Kingdom. Very fortunate that I have experience when I was in the UK. So as the history of the public transport development process in West Midlands, UK, in the 50s, public transport was the backbone of urban transportation. But with the automobile era, the public transport deteriorated. In connection with the emergence of an acute transportation problem, the provision of public transport is revitalized gradually by reducing car access and increasing access to public transport, pedestrian, and cyclists. And also the provision of large capacity public transport such light rapid transit supported by bus as a feeder. Using public transport is changing culture and processing. And sometime in developing country, the authority do not know about this. For example, in Indonesia, in one larger city in Palembang, they try to build the public transport strict to like rapid transit without any process. So this is very, very difficult to maintain the people to use public transport, because people will move from personal vehicle to use public transport is take a time and depend on the quality of a public transport. Next. So in this presentation, I would like to share how the public transport revitalization in Surakarta city. Surakarta city, we call it Solo, is a large city with an area of 44 kilometers square with a population of about 500,000 people. Actually, Solo is a sustainable city with multimodal transportation, a livable city. Public transport is the main mode of transportation. There are 12 bus operators serving 21 microbus routes with 260 fleet and one paratransit operator serving 10 minibus routes with 390 fleet. Next. Next. However, the existence of public transport experienced a significant degradation after the implementation of the automobile leasing program. This program is the vehicle purchased by installment. It means the people can buy car or motorcycle just by installment. So it attracts people to buy automobile, and this caused the public transport user drop drastically, and it creates a problem in transportation. So to improve public transportation service, especially for bus, on September 12, 2010, a transit-based public transportation was opened with a new bus fleet called Batik Solotran, or BST, with operator of Damri. And continue with on February 25th, 2014, open corridor 2, 3, 4, 5, 6, 7 with operator for PT Batik Solotran, and corridor 4 and 5 with operator of Damri. Next. In order to get a good public transport performance, then the existing 25 microbus route, which is intersect each other, was changed to become 7 routes with 2 operators. As I said before, that in Solo has 12 operators, and now they merged into 2 operators. in order they operate the public transport in Solo city. Unfortunately, corridor 4 to 8 could not be run because they were rejected by minibus operator. It is feared that it will reduce revenue of the minibus operator due to the minibus route intersect with PST corridor. In connection with rejection by the Paras Transit operator, therefore only corridor 1, 2, 3 are operating in Solo city. Next. To improve the public transportation service minibus, on April 6, 2017, the old minibus fleet has been replaced with the ST feeder fleet, with new fleet with new facilities that provide passenger comfort. This aims to attract community interested to use public transport. Next. Next. Hello. This is the challenging in the development of transportation based on public transport in online transportation era. The PTV performance, actually, after we provided a 3 corridor for Batik Solo Tran and also for the microbus with 10 routes, the public transport performance has improved actually for until 2016. For example, for the ST bus corridor 2. From 2014 until 2016 increase, but it is declining when online-based transportation is booming in Indonesia in 2017 until 2019. This is because the existence of online-based transportation service provide easier accessibility, connectivity, and low price of service compared to public transportation, thus causing people prefer to use online-based transportation. In Solo, they have online-based transportation like Gojek, Grab, and also Maxim, Uber, etc. And this make a nightmare for public transport operator. They lost profit massively. Next. This phenomena is of concern of the Surakarta city government to provide public transportation service that can compete with online-based transportation and private vehicle as mandated by law number 22/2009. For this reason, an innovative public transport service system is needed. The system used is by the service. Government have to help as a duty. In this case, the government as a regulator buy public transport service to private parties, namely operator, to serve the community as a user. Purchases are made based on calculation based on the vehicle operating cost, which will generate rupiah value per kilometer. So in this case, the operator will be paid based on the value of travel in rupiah per kilometer. The goal is that the government do not seek regular revenue, but the government improve the quality of public transport as a form of service to the community. Next. In order the Batik Solo tram using by the service program is successful, therefore some effort were made. Firstly, we have to revitalize corridor route. Corridor route of BST and feeder BST, which is a long route intersects each other, overlap each other, do not integrate, need to be changed. As you can see on the left-hand side, on the top is the route of BST bus and BST feeder, and if they combine to become one route, so it's look really messy, do not connect each other. So therefore, the first step is to make the route is integrate between one in another, between bus and feeder. And also this route also integrate with the Trans-Jateng Corridor, where the Trans-Jateng Corridor is, which is the public transport between the region near the city, near the Solo city. The next. Next. The next step is traffic management and engineering. As you can see on the picture on the left, on the top, the existing route need to be changed. The existing route from east to west, as you can see, the dot line diverted to southern road, and this is not profitable because they do not the same lane, the same route in Brigjen Slamet Riyadi. So therefore, the route is made the same as the west to east direction using one-way system with the traffic flow system. In this case, if you can see that before route is going southern, and now they have to scrap and they change to the new route, the same with the route from west to the east. In this case, we have to change the system that the road before is one-way system to become one-way system to with the contraflow bus lane. Only one lane for special bus, BST, from the east to west. And also, in this case, in order to increase the reliability of public transport, therefore, later will be installed bus priority traffic signal control at intersection. Next. The third is the implementation of the operational system. The operational system, in this case, with implementation of intelligent transport system, in order to provide service that are safe, comfortable, reliable, affordable to the public transport passenger. There are a number of ways to provide on this system, such as a rider appeal. Rider appeal is very important. It provides a gadget, so the passenger can see from the gadget the route of PSD, where the bus is in the network, and also the service schedule, the frequency. And the next is a fare collection. This is based on the cashless. The idea is to reduce minimize the time of the bus stop in the shelter. So this can reduce the travel time of the service. And the next is also provide safety system to avoid vandalism and also criminal action. And also there are a safety system to watch the driver. For example, if the driver is sleepy, then the security will notify the driver in order to always wake up and focus on the driving the public transport. The next. This is what we have done in the progress of providing public transport in Surakarta. When the COVID-19 happened, the number of passengers dropped very significantly because it's related with the health. So in order to provide a healthy service for public transport, Batik Solotran, so Batik Solotran follow the healthy protocol, like spray disinfectant after and before goes, hand sanitizer, check body temperature, and also the passenger have to use a mask. And this is the most challenging era compared to the two which I mentioned before, because in this case that the passenger have to follow distancing place where it will reduce the load factor of public transport. Next. From my point of view, that the public transport development is not easy, full of challenging and processing, and it needs government in commitment, and also transportation policy, also stakeholder commitment, especially for paratransit operator, which I already mentioned before. Paratransit operator is very difficult to join, to establish the public transport more integrate one and another, because sometimes they want to do what they want, they do not follow what the government want, so it is very challenging. And also the community participant. Regarding to the COVID-19, for the next step of development of the sustainable transportation in Solo City, that we have to provide or to make it better the pedestrian and also cycle lane, which already it's already in Solo City, especially on the main road in Solo City. As you can see on the picture, so the first is the bus lane contraflow. This is to provide public transport, and this need to be supported with the infrastructure of the pedestrian, what we call it a city walk, and also the cycle lane, which is the non-motorized pedestrian, and also the cyclists is part of last mile and first mile for the transportation. So what I mean that the sustainable transportation can be achieved if public transport supported by pedestrian and cycle. And thank you very much for listening my presentation. I hope this presentation will provide benefit related to the process of developing public transport in sustainable Surakarta city. And I do apologize, maybe I'm not telling much about the progress of transportation, especially on the bicycle in Solo City, because right now we still doing studying about how to improve the pedestrian and cycle infrastructure to support the public transport. Thank you very much. Thank you.
So thank you very much, Dr. Budi Yulianto, for that very illuminating presentation. So reminder again, dear participants, please access the chat box for your questions, and please indicate your name or name of your organizations in your country so that we can address you during the Q&A portion. So over the next 20 minutes, we'll be listening to a professor of research from the Neuva Ecija University of Science and Technology in the Philippines. He is a faculty of the College of Engineering, Electrical Engineering Department in UST, and he is a Master in Engineering Education, major in Electrical Engineering. He's also the chairman of the Electrical Engineering Department and the research coordinator of the College of Engineering. He has published researches on international refereed journals such as Scopus Index and Thomson and Reuters, and also to local journals and publications here in the Philippines. He was also invited to speak about research methods and research culture in some universities and colleges in Nueva Ecija. That's why, ladies and gentlemen, we're privileged today to have him speak to us the topic establishing professional probity in research culture of engineers. The importance of this topic to us here is raising awareness of the centrality of research integrity to the research ecosystem, for us to be aware of how research misconduct can inflict damage on the research community, on academic institutions, and on society as a whole. So ladies and gentlemen, join me welcome a friend, a colleague, a good leader from the Nueva Ecija University of Science and Technology, Philippines, Dr. Salvador Loria.
Thank you, Ma'am Gina. Ma'am Gina, can you please share my screen?
Yes, sir.
My screen. Can you please share my screen?
I cannot share your screen, sir, because you are the, I don't know who's the host. I think the host can share your screen.
Can you please advise the host to share my screen?
Calling the...
Okay, wait. Wait me for a while.
Sir, your screen is now...
Okay, ma'am. Thank you. Good afternoon, everyone. First, I would like to extend my appreciation and gratitude to the Nueva Ecija University of Science and Technology and to the Universitas Tunas Pembangunan for inviting me to be part of this international. The topic assigned to me is establishing professional probity in the research culture of engineers. Well, as a professional, as an engineer, we are mandated to perform our tasks with honesty, impartiality, and integrity. It is already given. That's why we have code of ethics in our profession. This will serve as our Bible or reference in practicing our profession. Much more than to any other profession, the researchers should have a high moral ascendancy to uphold integrity and probity in their research tasks. So we need to create a positive research culture where researchers embrace integrity and probity. Why? Because the product or the output of research lies on the integrity of the researchers. So to enlighten us more on this topic, I formulated topics, and this is the focus of my in our today lecture. First one is strengthening the research culture. This is not an easy. Sad to say that some of our engineers, they have a lot of misconceptions and notions about research. So some of them, of course, they don't want to participate research for many reasons. No? And then another is about the ethical issues in research. So until now, there's no clear issue regarding the ethical issues in engineering research. So when they talk of ethical issues, they thought that this is only research applicable to social science research or research involving human experimentation and animal welfare. How about, let's say, if my research is about, let's say, about software engineering, or my research is about engineering process and design, or let's say my research is developing a new technology. The question is, do I need to secure clearance from the ethics committee? So we are going to enlighten that later on. Another is misconduct in research. Sad to say that this is continue to proliferate in the research community. And we have to be aware what are those misconducts in order for us to avoid as a researcher. And then, why probity or integrity in research is important. So why we need to establish an integrity into a researcher? What is the implications? Why we need to have a public trust, or why that the public need to be trusted to our researchers? And the last is, how do we make sure probity in our research? So let's start first with strengthening the research culture. So when we talk of research culture, it's all about the behavior, the values, the expectations, the attitude and norms about research community. If we want to have an excellent research, we need to create a positive research culture where all individuals in the community, where all individuals in the organization or university must be involved and must be participated. So we need to provide a research enhanced environment. So the organization or the university can provide ICT hub, since nowadays this is very essential in delivering our work. And the university also or the organization can provide support laboratory infrastructures, research and development center. So by putting all these infrastructure can provide an enhanced research environment. Then facilitating open discussion can help foster a more collaborative environment. So we need to have a congenial relationships among faculty members in order to support a successful faculty to faculty research mentoring. We need to provide a collaborative environment so we can do group research, team research, where everyone in the community, everyone in the organization can participate or have a participation in the research program of the university or the organization. Then, establishing support system can boost morale and enhance a positive research culture. So we have to provide or promote career counseling, coaching, and support services. These may help to reduce the uh, uh, the pressure in the research environment. So we need to establish or we need to boost the morale of our researchers. Then we can provide a research culture cafes. So this is we can uh, we can find time and space where our researchers can share their ideas, their experiences, uh, their best practices. So with that, it can provide or it can strengthen the research culture of our researchers. Then we can do embed research culture at an institutional level. So highlight the importance of research culture and engage all staff across the organization. So by hosting, let's say, a research culture day or an in-house research review. So, and the last one is research recognition. So this is very important. So we have to recognize the effort of our researchers. We can do it in terms of monetary form or in terms of plaque of appreciation and recognition. What most important thing is we recognize the effort of our researchers. Ethical issues in research. Actually, ethical issues uh, it is not arise only in the research community. It is arise in all form of professional practice. So when we talk of research ethics, they think about issues that arise when research involving human or animal subjects. So while these issues are indeed a key part of research ethics, these include the importance of publishing findings in a transparent way, not plagiarizing other works, and not falsifying work. So they have uh, a lot of misconceptions about research ethics. They thought that research ethics is only applicable for social science, for health and medical science research, or for clinical studies. How if, let's say, my research is about engineering? So let's say I am developing a new technology or new device. So completing the technology, completing the device, completing the development of the device, that is only the first phase of research. So the research will not be completed if this research will not be tested to the community. So we need to test the effectiveness, the safety, the reliability of the researchers. So in order for us to do that, we need to utilize that in the community. And in doing that, of course, we need a human subjects. We need human participations. And it may probably, of course, when we conduct pilot testing, it may inflict to our environment. It may inflict to some cultural heritage or some other resources. So with that, we need to secure or we need to follow the ethical issues. No? We need to follow the ethical guidelines. Okay, so engineering research, such as development or assembly of device, requires testing the effectiveness, the safety, and the reliability to complete the research. So we need to conduct, as I said, a pilot testing to the end user. Ethic assessment of engineering refers to any kind of assessment, evaluation, review, appraisal, or valuations of research or innovation within engineering that may use of ethical principles or criteria. So meaning, when we conduct ethics assessment in engineering research, we use the same principles, we use the same criteria, we use the same instrument. Okay? So ethical issues in engineering research, this may involve scientific integrity, social responsibility, human research, subjects research, and animal welfare. So engineering innovations may give rise to the same issues as well as issues relating to social responsibility and issues concerning impact of technology that may relate to the environment, health, and public safety. Like for example, let's say your field is chemical engineering and you're doing research, let's say toxic byproducts in the creations of chemicals. So some of the issues there are, of course, the issues in the long-term effects of exposures of new chemical. There's also an issue there in environmental issues. Okay, so how about let's say your research is about robotics, no? So there are also issues there, like for example, well-being and safety issues, ethical issues concerning aerial vehicles such as drone, which is violations of privacy. Let's say your field is civil engineering and your research is about safety of built structure, destructions of cultural heritage, earthquake engineering, risk analysis for hazard mitigations, and water resources management. So this may inflict to our natural resources, to our environment. Or let's say your field is environmental engineering. And of course, there are issues there like ecological restorations or ethical issues with geoengineering. Let's say you're going to drill or explore a explorations for productions of oil or gas. Or let's say your research is about nuclear technology. Okay, so development of nuclear weapons, and of course the issues on problems of waste disposal. So there are a lot of issues in engineering research that may directly have an impact to the human, to our environment, as well as to our company. So with that, we need to follow the ethical research guidelines. Okay, so misconduct in research. Sad to say, this is con- uh, this is uh, this is continue to proliferate in the research community. Okay, and we are aware of that. Okay, so that there are misconducts happening in the research community. Now, when we talk of misconduct, of course, this is the violations of the standard codes of scholarly conduct and ethical behavior in professional scientific research. So publication. So when we say publication, meaning you made up the data, you invented the data, you did not gather the data accordingly. So falsification meaning you altered the result of your research favorable to your own interest or favorable to the interest of the other parties. And plagiarism, this is common, no? Taking another ideas, taking the content of the another author without giving an appropriate credit or acknowledgement to the original author. Then another misconduct is deliberate, dangerous, or major deviation from accepted practice in planning and carrying out research or in applying for funding or other forms of support. Then, facilitating misconduct by colluding, concealing, or ignoring such actions. And unauthorized use of intentional misuse that can cause damage to the properties, research-related equipment, and other resources. Okay, so why probity or integrity in research is important? So when we talk of integrity in research, it's all about the performance of research to the highest standard of professionalism and rigor in an ethically robust manner. So meaning the research must meet the extremely thorough and accurate testing. Okay? So let's say your research is about drugs or about consumer products. So what will happen if the research was not met the standard, the highest standard, and it was not underwent a rigorous testing? So consumers or the community or the end user may put in risk. Research integrity create trust. So of course, we need that researchers must be able to trust each other words. And they must also be trusted by society since they provide scientific expertise that may impact people's lives. Like for example, let's say there is a group of researchers and they are developing a research on vaccine on COVID-19. So how if the people in the community or let's say this group of researchers they did not gain the public trust. So let's say the people in the community, let's say they are not trusted to this group of researchers. So what do you think will happen? Of course, you cannot force them to be vaccinated. So if they don't do that, then the whole objective of research will be failed. The whole program of research will be defeated. So we need that researchers, we need to gain public trust and public confidence. Then it maintained the reputations of the university as a research intensive institutions. So built on the consistently high quality research conducted by the staff and faculty. So it is important that everyone involved in the undertaking research communities to meet the highest accepted standard. So by establishing the integrity in the research community, in the research culture, it maintained the reputations of the university as a research intensive institution. Okay, so the last one is how do we make sure probity in our research? So honesty in all aspect of research. So from the presentations of our research goals and intentions and reporting the findings, the research methods and procedures that we use, the data gathering that we do, conveying valid interpretations and making justifiable claims based on research findings. Although we can corroborate our results to other researchers' work, but basically the results of our research must be based on our findings. That's all. So our claims, our interpretation must base on the results or must be based on the findings of the research. Then transparency and openness. So we have to be transparent, especially in declaring conflict of interest. So as we all know, conflict of interest arise when a researcher's interpretations or judgment is influenced by a secondary interest. So this might include some personal benefit or an interest that may impair the objectivity in conducting the research. So we have to be open and transparent in the reporting of our research data collection method, in the analysis and interpretations. So making research findings, what it must be widely available. And we have also to be transparent and open, even the results is negative. So we have the responsibility to share the results of our research to the public, whether it is favorable to what we are expected or even it is contrary to what we are expected. And care and respect. So we have to respect for all participants. So including human, including animal welfare, no? The environment, the cultural heritage or the cultural objects. So we have to ensure that ethical standards must be properly followed. Okay, so that's the end of my presentations. So I hope that with this short talk, I encourage and inspire our engineers and researchers to keep and maintain probity in our research culture. Practicing research integrity is not an easy. Recognizing our own ethical lapses are more even difficult, but we need to work together. We need that our researchers must be trusted by the public. We need a confidence from the public. So we need to work together in our organizations to create a positive research culture. Because when we talk of research, it's not all about professional and career development. It's all about responsibility. Responsibility to the human, responsibility to our community, responsibility to our environment, and responsibility to our country. Thank you and good night.
Well, share this. So thank you very much, Dr. Salvador Gloria. That was very enlightening presentation. So hello there once again. Are you still with us? Yeah. So you have to hang on with us because we will be hearing another 20 minutes of very educational presentation from our last but not the least speaker. He will talk about a systematic approach to reduce or eliminate activities that don't add value to the process by a data-driven problem-solving methodology. This topic is important to engineers since they generally work on complex operations involving many different processes, people, and projects. This can prove useful, particularly for industrial engineers who oversee large-scale manufacturing processes with a focus on making them more efficient. This is also important for all engineers working in the industry since we are working towards Industry 4.0. Our speaker is a professional industrial engineer, Master of Engineering in Industrial Engineering, and a certified Six Sigma Green Belt. His work experiences include planning and development consultant, reliability engineer, qualifications planning, capacity planning, work instruction engineer, quality assurance, quality control, management innovation, innovation engineer, process control engineer, Six Sigma Green Belt for Sydenham Laboratories Incorporated, and air traffic control officer engineer, Civil Aviation Authority of Singapore, He is now a faculty of the College of Engineering under the Industrial Engineering Department. He will talk about Lean Six Sigma. So once again, ladies and gentlemen, we are privileged to welcome our speaker, a colleague, young and good-looking, dynamic engineer, Rick Donald Manson.
Thank you very much, Miss Gina, for the wonderful introduction. Good afternoon, everyone. And I am Rick Donald Manzon, speaking from the Philippines. And I would like to greet Professor and Dr. Tresna Priyanya Mardi of Rector of UTP. Thank you, ma'am, for having me here this afternoon. And also Engineer and Dr. Feliciana P. Jacoba, University President of NUST. Also, Attorney Eric Claudio, the Head of Office of Institutional and Domestic Institutional Linkages of NEUST. And to my co-presenter for this afternoon, Dr. Budi Yulianto and Engineer Salvador Loria. Good afternoon, everyone. So thank you for the College of Faculty of Engineering and International Office of Universitas Tunas, Pembangunan, Surakarta in Indonesia for having me this afternoon. And to the College of Engineering, Training Department, and Office of International and Domestic Institutional Linkages of Nueva Ecija University of Science and Technology in the Philippines. Mabuhay. Assalamualaikum, everyone. And I'm very excited to share with you my presentation for this afternoon. Salamat Sure to our viewers in Indonesia.
Salamat, Sure.
Did I say it right? And magandang hapon and mabuhay for our Filipino viewers and to all nations participating for this afternoon. Good afternoon. This afternoon, I was given 20 minutes to discuss Introduction to Lean Six Sigma. So if you have questions and if you have clarifications about my presentation, short presentation for this afternoon, please email me or I'll be sharing with you my communication details so you can throw in me questions and further clarifications on my presentation. For our moderator, can you please let me have control of my screen, please?
Okay, sir.
Okay.
That will be
Can you see my screen now?
not yet. Sir Yafi.
Please let me have the
Sir
control
Yafi.
of the presentation. Please share my screen. Thank you.
Yes, you can share your screen. You can share your screen now.
You can see it now?
No. No, not yet.
You can share
Not
your
yet.
screen, sir.
I'm sharing it now.
Okay.
Share screen. Okay. Share. So for this afternoon, I will be discussing Introduction to Lean Six Sigma. This is for the use of professionals in the field of engineering. So my content for this afternoon would be the history of Six Sigma, a brief history, what is Lean, what is Six Sigma, what is DMAIC and the MADV. So that's the MIC and the MADV, and a little computation of Six Sigma for us to understand more. So some application, case study, and I will be catering questions from our viewers. Okay, the moderator, Miss Gina, already presented who I am. So thank you very much, Miss Gina. A little bit disclaimer. If you will be using any parts of this presentation, please let us know. And you please use proper citation and acknowledgement. Okay. So before we start, the first question is likely what is Six Sigma? So most of you haven't heard or have a little idea of what Six Sigma is, right? So the most second question would likely be why Six Sigma? Why are we go? What is Six Sigma and why are we going to use Six Sigma in our daily lives? Okay. So let's talk about how good is good enough. So this pandemic has already been trying to make us use alcohol, right? And antibacterial soaps. They are always telling us to use those soaps, and those products are always telling 99% good, right? So most products are always 99% good, 99.9% good. But what is 99.9%? Is it really that good? So let's examine. In Six Sigma, uh, it it can we can tell that 99.9% using let's say 1 million parts samples, that is only 4.6 sigma when we compute it into sigma in terms. So when we evaluate it and put it in our daily lives, 99.9% is equivalent to, let's say for example, 4,000 wrong medical prescription each year. For example, you are asking your doctor to have your prescriptions ready. So there is a chance for 1 million samples or 1 million patients, the doctor can give 4,000 wrong medical prescription each year. That is 99% already, not 0.9%. Okay. So another example is there should have been 3,000 newborns accidentally falling for the hands of nurses or doctors each year. For 1 million babies being born, so there is 3,000 newborns that will be accidentally be falling from your hands or to the doctors or nurses' hands. Also, 99.9% also is equivalent to 2 long or short landings on every American airport each day. So that is 99.9% good. And there will be 400 letters per hour which every will never arrive in their destinations. Okay, per hour 400 letters. So that is 99.9% good. Let's say for example, let's put 4,000 wrong prescription into 13. Not quite good enough for me, but 13 is better than 4,000, right? And 10 newborns being dropped by the doctors or nurses per year. From 3,000, let's make it 10 to make it more acceptable. And 2 short landings again for the airports in every US airports, and 1 lost article per hour. So that is Six Sigma. So that is the difference between 99.9% and Six Sigma. So what is Six Sigma? So the term Six Sigma is used in statistics to represent standard deviation. I believe everyone who is listening is in the field of mathematics and engineering. So we have taken basic statistics and engineering statistics. So there's no need for me to elaborate on standard deviation, right? So from the mean value, this is an indicator of the degree of variation in a set of a process. Okay. Also, Six Sigma measures how far a given process deviates from perfection. The higher sigma capability, the better performance. Okay. Also, Six Sigma is a highly disciplined process that enables organization to deliver nearly perfect products and service. Okay, please take note of this one. I am saying nearly perfect products and services. When I say nearly perfect, I am not claiming that Six Sigma is perfect, making it perfect, nearly perfect, as perfect as possible. Okay, and it perfects products and services. It can be applied to anyone who is doing products or delivering services. So if you're on the product side, manufacturing side, it's okay. You're in the service side, or in the government, you're in banks, you're in educational institution, it's okay. Also, the figure of Six Sigma arrived statistically from current average maturity of most business enterprises. So imagine you have the possibilities of Six Sigma is limitless. It can be applied everywhere. Okay. So this is also a philosophy and goal as perfect as practically possible. So I've said that a while ago. And also a methodology and a symbol of quality. So as an engineer, as a technician, as a scientist, as a doctor, or any other professions, we wanted to deliver our service, our products on its quality level, right? And a statistical concept that measures a process in terms of Using defective items or services. So Six Sigma is identifying and removing the causes of defects before it happens. So it uses a set of quality management methods, mainly empirical, statistical methods, and creates a special infrastructure of people within the organization who are expert in these methods. So if you will be, I will be highlighting this one, people within the organization. So I would like to put emphasis on that because we wanted to have an idealistic and true approach on how we are going to solve our problems, that we are looking for someone who is knowledgeable on systems and processes within the organization, not just like looking for some related literatures of something that who has the same product or services, and we will be just applying it on our process that is not will be totally answering our problems. So Six Sigma also is to reduce the process cycle time. We also wanted to reduce the pollution. We also wanted to reduce the cost, my favorite one, and increase customer satisfaction. And also, all of our favorite is to increase our profits, right? So that is Six Sigma. So our old belief, high quality is equal to high cost. For example, if you will be buying merchandises, if you will be buying clothes, if you will be buying shoes, if you wanted high quality items, you would look for the costly one. Like for example, on shoes, what would you pick? A Nike, an Adidas, right? Because it's costly. So the new belief using Six Sigma is high quality can also be low cost. Better processes reduce the cost. Okay, for example, a very good example. If we will be manufacturing, for example, a pen. Okay, a pen. We will be producing a pen. So let's say for example, the cost of this pen is like 20 pesos or like 30 Indonesian rupees, right? So if I want to make this one more viable for my customer, what should I do? The normal thinker will just suggest that we look for cheaper raw materials of this one, right? To make this one cheaper and to make this one affordable. But if you will be using Six Sigma on that in that case, we will be examining how this ball pen is being produced, and we will be evaluating and looking into the process of how are we going to make this one work on the lower cost possible without contemplating or issuing the quality of our material. So that is Six Sigma philosophy. So let me remind everyone that Six Sigma is not a standard. Also, Six Sigma is not a certification, but there is a certification for this one, and not another metric like percentages. Rather, Six Sigma is a quality philosophy and a way of improving performance by knowing where you are and where you could be. So this is evaluation, where we are today and where you can be. So methodology to measure and improve companies' performances, practices, and systems. Okay. So why Six Sigma? Six Sigma emerged as a natural evolution in business to increase profit by eliminating defects. And the current business environment now demands a reward innovation more than ever before due to we are all experiencing it now. Customer expectations. Okay, our customers expect more than they are paying for. The next one is technological change. From time to time, every time technology changes and we must be updated to it. So your cell phone 5 years ago is not that technologically savvy as if compared today. Okay, your Nokia 3310 way back 2000 is not that useful into your iPhone today, right? So technological change. So global competition, of course, and market fragmentations. So let me show you Six Sigma level process capability when we are using, for example, 1 million samples. If we will be standardizing it to defects per million opportunities, we are on 2 Sigma level process capability when we have at least 308, 537 defects per million. So that is 2 Sigma level process. Okay. So we are on third level of Six Sigma when we have 66,807 defects per million. Okay. And for 6,210, 233, and what I am saying a little bit earlier, we are only allowed to have 3.4, or if there is no point 0.4, if you cannot divide your products, let's say for example there is no point 0.4 cell phone or there is no point 0.4 television, right? So at least 3 defects per million opportunities, you are on to Six Sigma. So that is how are we going to compute for the Six Sigma. Okay. So what companies are using Six Sigma as of this moment? So it started by Toyota. So we have Toyota. They are using it. Motorola, Sony Ericsson. We have GE, Ford. We also use this in banks. We have Citibanks, Maybanks. In the Philippines, we are using it in East West Bank, PS Bank, because we who in here wanted to fall in line in banks for so long, for a single deposit or withdrawal that would cost you around 30 seconds of transaction, and you will fall in line for like 3 hours and 8 days, right? So that is not acceptable for us. And also governments are using this, like for example the government of Canada is using this for their services. Also the White House for in the Philippines and in Indonesia. I hope this one is will be used in the governments, especially you are going to have transaction like driver's license, getting driver's license. You can eliminate the waiting time, the too much waiting time for a single documents or the government documents and so on. So we have Google and hospitals. They are using this one, and also importantly, airports, airlines, and merchandises. So they are the one who is using Six Sigma as of the moment. So let's compare for you to have a background: a Three Sigma company versus a Six Sigma company. So a Three Sigma company spends 15 to 25% of sales on dollars on the cost of failure. On Six Sigma, we spend only 5% sales on dollars on the cost of failure. Okay, for example, the best example of this one is warranties on your electronics appliances, right? So if you are the company and you are not and your products are not that reliable, you will be spending 15 to 25% of that, of your total income or money on the cost of failure. Like for example, replacements, services, warranties, and so on and so on. But a Six Sigma company is very confident that their products will work. Okay, that there should only be 3 items per 1 million that will not be functioning. So that is 5%. Okay, so a Three Sigma company will rely on inspection to find defects. The one that I am telling a little bit earlier. We look for wrong. We look for defective on our bare eyes, already been produced, already been given, and we are looking for defects. Okay, a Six Sigma company relies on capable process that don't produce defects. Okay, that's a big difference. There's a big difference between the two. So we look for the processes that will not produce defects. Okay, so which one would you choose? On a Three Sigma company does not have a disciplined approach to gather and analyze data. We just pick and go, and something like that. So in Six Sigma, we use measure, we analyze, we improve, we control and measure and analyze and design. Okay. So we have a proper steps. In Sigma, Three Sigma company, we benchmark their selves on their competition. Very good example here in the Philippines. If I will be producing a certain product, let's say for example, I will be producing a germicidal soap, I will be just looking against my competition. So if I will be brand X, I will be just looking at my competition brand Y. In Six Sigma, you benchmark yourself against the best in the world. So broader, wider, okay? And Three Sigma company believes that there is 99% is good enough. In us, in Six Sigma, we believe that 99% is unacceptable. Okay? We don't want 4,000 babies being dropped by doctors. We don't want 4,000 wrong prescriptions a year. We don't want two short or long haul landings of airplanes. And we don't want any more defective products and services that we will be accepting. And we defined CTQs internally in Three Sigma, and we defined CTQ externally in Six Sigma. Hello there, baby. How are you? Okay, let's proceed. So we have Six Sigma trainings actually that you can enroll in if you were interested. Later on, I'll be discussing. So there is three Six Sigma belts that is for everyone that would wanted to have thorough training for this one. So for green belt, we utilize a statistical quality technique. The consultation time for this one and training is 2 to 5% of their working time. So we have mentoring, and you have to do 2 projects per year. So you can do black belt training, so that is 5% to 10% on consultation and 4 projects related. And also we have master black belt. So 80 to 100% of your time doing Six Sigma, and you have to have 10 projects per year. And the last one is the champion. So 100% of your time you will be doing Six Sigma, and 10 or more projects every year. Okay. So we have three Six Sigma methodology. The BPMS, which is the Business Process Management System. So we also have the MAIC. So I will be discussing further or more later on. So Six Sigma improvement methodology, and the MADV, the creating new process which lead to perform at Six Sigma. Okay. So let's pause it for Six Sigma and let's discuss Lean. Okay. So lean methodology, on the other hand, is a systematic approach to reduce or eliminate activities that don't add value to the process. So that is lean. So it emphasizes removing wasteful step in a process and taking only the value added steps. So we are looking for the one that adds value and remove to those things that is not needed. So the lean method ensures high quality and customer satisfaction. So it helps in reducing process cycle time. It helps in improving product or service delivery time. It helps in reducing or eliminating the chance of defect generation, and reducing the inventory levels and optimizing resource for the key improvements among others. It is also a never-ending approach to waste removal and promotes a continuous chains of improvement. Okay, very good example of lean methodology for you to understand. Look, imagine opening your bags. Okay, and for example, your objective for today is go to your offices, go to your works, go to your classes, right? And try to open your bags. Okay. Which among the items inside your bags are non-value added? Which are the things that you don't need to your daily objective? Oh, so I have a colleague, a female colleague who has microwave oven in bag. You have flat iron, you have rollers, and so on and so forth. That brings in weight in your bag that you don't really need, right? The only thing you need on office is your laptop, maybe your cell phone, maybe your wallet, yes, your cell phone. But bringing in oven toaster, refrigerator, and flat iron to your is not needed. It just add up weight and additional effort to you, and it consumes space, right? And so on and so forth. That is lean. So by removing waste, the lean concept obtained its genesis from or its beginning in TPS or Toyota Production System. So one, the Japanese call this term as muda, 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 which is uh, uh, introduced by my favorite engineer, Engineer Taichi Ono of Toyota in 1916. So Mr. Taichi Ono identified 8 kinds of waste, acronym as downtime or DOWNTIME. So downtime is waste in defects, overproduction, waiting, my favorite one, waiting, non-utilized talents. I believe you experienced that, your colleagues, non-utilized, your transportation, traffic, yes, inventory, excessive motion, unnecessary movements, and so on. That is motion and extra processing. So that is downtime, defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. So this is it. So we have to from my material, you can identify which is considered as a defect, overproduction, waiting, and so on and so forth. So the lean methodology tools uses lean methodology that introduced to some important tools. We are using value stream mapping. So if you are familiar with value stream mapping, Kaizen, so JIT or just in time. We also have SMED or single minute exchange of dice. We have Pokayoke, a mistake proofing device, Jidoka or automation in Japanese, Heijunka, line balancing in Japanese, Gemba or Go and See, and Kanban. So I will not be elaborating that methods for you to discuss more. So Lean Six Sigma in American Society of Quality is a fact-based, data-driven philosophy in improvement that values defect prevention over defect detection. So that is it. So we'll be elaborating in more furthermore. So let's combine Lean versus 2 Six Sigma. So Lean, the goal of Lean is to improve the process performance through waste elimination or the MUDA, while Six Sigma's goal is to improve the process performance in relation to what is critical to the customer. So we have BPMS, DMAIC, and DMADV. So the focus of Lean is bias for action. So the focus of Six Sigma is bias for analysis. Okay. So the methods used in Lean is implementation of a Lean tools such as Kaizen, value stream mapping, 5S, TPM, if you have heard it, etc. For Six Sigma, we uses the MAIC, the MADV, and BPMS. And the deployment of Lean is implicit to infrastructure, and Lean Six Sigma is explicit to infrastructure. So our objective with Lean is speed, flow, and cost, while on Six Sigma, customer satisfaction. All in all, the combination of Lean Six Sigma will give us uh, the Lean focus on waste elimination supports Six Sigma quality, while Six Sigma quality supports Lean speed. So that gives us Lean Six Sigma. Okay. So in BPMS, let's go back. So in Six Sigma we have BPMS, the mic, and the MADV. Just to give you a short information of this one. BPMS is BPM strategies and emphasize process improvement and automation to derive performance. Okay. So we are using 7QC tools. So the mic stands for the acronym define, measure, analyze, improve, and control. And the MIC stands for define, measure, analyze, define, measure, analyze, improve, and control process. So while the MADV is define, measure, analyze, design, and verify. So we will be using BPMS if we will be needing immediate action to our problem. If we have time, we use either the mic or the MADV. We use the mic when we have a current process existing. Okay, we will be using the mic. We will be using the MADV if we have a new process, non-existent process, and we wanted it to be made. So will be the mic. Okay, again, BPMS, if we will be needing immediate response or immediate answer to our problem. If we have time, a little time, we use the mic or the MADV. The mic if the process is existent process, or the MADV if it is a new process. Okay. When should Six Sigma be used? Okay. It is used depends on the type of business in general. If there are a process that generates a lot of negative customer feedback, whether that customer is internal or external, the component of Six Sigma should be considered as mean to study and rectify the problem. In short, we can put Six Sigma everywhere. Again, we can put and apply Six Sigma everywhere. Okay, imagine a system or organization that has any of these five. For 5M1E, remember that. Man, material, methods, machines, and environment. If there is at least one present in that organization, we can use Six Sigma. Again, man or people, machines, method, materials, and environment. If there is one existing, we can use it there. Okay. So we have benefits of Six Sigma. Syempre, it generates sustained success. It promotes learning across boundaries. It accelerates rate of improvement. So it executes strategic change. It sets performance goals for everyone and enhances value for customers. Okay. So I will be giving you a short case study on Six Sigma for you to have a visualization on how we are going to use it. For example, my company X, this is my output for 6 months. Yes, 6 months. So from January to June, my output is this one on this table. So I have 1,052, 1,032, 1,055 outputs. Okay, that is my total product. So I have a defect of 8 on January. On February, I have 9. On March, I have 12, 11, 5. On 6 months, I have 53. So computing for the percent difference, I have 0.84%. So if I will be computing it into million opportunities, so I'll be using a very simple mathematics using cross multiplication. So I have 53, my total defects over my total output. So I wanted to identify the X over 1 million samples, right? So multiplying, eliminating, very simple. So my X would be 8,427 units. Oh, I don't have 0.41, so I'm assuming 8,428 units. So I can say that my company is on 3 Sigma level capabilities. So I have 8,422 units. So that would be on 3 Sigma level capabilities. Okay.
Excuse me, sir.
Yes.
We only have, I think, 1 minute left for that.
Okay. To sum up, okay, not a problem. Okay, thank you,
Yes.
ma'am. So I can say that my company has experienced 3 Sigma process capability producing units product with 8,428 unit defect per million, amounting to, let's say, for example, my unit is 18,500 per unit cost. That is 155,918,000. So this company study is actual company study from Toyota Manufacturing System. Okay. So if you have more questions regarding Six Sigma and you wanted to learn more about Six Sigma, I am very happy to announce to everyone, please visit us at facebook.com/iexceedph or email at, or you can scan the barcode there. So for you to understand more on Six Sigma, we are giving free webinars also in Six Sigma, and it will be very beneficial to every engineers out there. So if you have questions for me, I will be happy to answer that. If I'm single, yes, I am. I am looking. No, I'm not. So please message us. And thank you for having me here this afternoon. So we have a very short and limited time, but I hope I've shared some good ideas and some good outlets for you, everyone out there. So thank you very much again, ma'am, sir.
Thank you very much, Sir Dr. Manzon, for that very educational, enlightening, illuminating presentation. So hello there, everyone. Thank you for hanging out with us until this very moment. You're still there? So it's now turn for our speaker to answer your questions. Some questions may not be accommodated, but we apologize for that. That will be answered on through your emails. And again, please don't forget to fill in the post evaluation on Google Forms, which will be posted on the chat box at the end of this webinar, and for your claiming of your e-certificates. Okay, so for the questions, before our questions, so let me introduce again the speakers for today. We have, from UTP, from Universitas Negeri Sebelas Maret, Surakarta, Dr. Budi Yuliano, on the topic of collaboration on mass transportation, bikers, and pedestrians. Nueva Ecija, University of Science and Technology, Philippines, we have Engineer Salvador A. Loria, on the topic of establishing professional probity on research culture of engineers. And again, also from Nueva Ecija, University of Science and Technology, Philippines, Engineer Rick Donald Manzon for the topic of Introduction to Lean Six Sigma. For the questions, the first question is from Efren de la Cruz. I think he is from Central Luzon State University, Philippines. Question to, he's from CLSU. Question to Dr. Budi Yulianto. Sir,
Hello?
How does the new normal situation in Indonesian public transport affect the take-home pay of public transport workers since the current situation? Hello? Hello, sir? Can you hear me? Hello? Hello? Hello, Dr. Yafi. Mr. Yafi, can you hear me?
Yes.
Yes, I can hear you.
We can hear you.
Hello, Dr. Budi Yulianto. Can you hear me, sir?
Hello, yeah, I can hear you.
Yeah, so this is your question, sir, from Efren de la Cruz of Central Luzon State University, Philippines. How does the new normal situation in Indonesian public transport affect the take-home pay of public transport workers since the current situation greatly reduced the number of commuters?
Yes, thank you for the question. This is a very bad situation during the Corona-19. If we look at the number of passengers, for example, if we use the data from the Transjakarta or the bus Transjakarta, that before COVID in January 2020, the number of passengers is about 840,000 per day. In April, after COVID-19, the number of passengers reduced, become 83,000 per day. So it means just only 10%. For the MRT in Jakarta, before the COVID is about 85,000 passengers, but after the COVID-19, it's only 5,000 passengers. So this is also just only 10% passenger. And for the train, before the COVID-19 is about 182,000. The train before the COVID, 859,000 passenger per day. But after COVID, is 183% per day, just only 30%. This is in Jakarta with a very good public transportation. For the Solo, it is much worse. For example, for BST, before the COVID and before the buy the service implemented, before the number of fleet is about 20 fleet, but after the COVID, only 2 fleet. So it means that the number of passengers use the public transport for the BST just only 5 until 10%. So it will affect the profit of public transport. So likely for the BST, but Solo Trans in Solo, during the COVID, we got subsidized from the central government from the by the service system. It means that 2 corridor 3 and 4 free of charge. So it means the public transport is still operating with full fleet, with the headway is about a 10-minute interval. So in overall, if we look at the effect to public transport, apart from the Batik Solo Trans and Trans Jakarta, I think it's very bad. So some of them do not operate as before the COVID-19. So some the operator want the government to give to ask the government to give the subsidized through by the service program. I think that is my answer. I hope you understand what I'm saying. If you want to ask more, you can send me by email. We can discuss more longer. Thank you.
Thank you so much, Dr. Rudy Julianto. Now, since we are running out of time, so we'll now move on to the second question to the second speaker from Martin. Question to Engineer Salvador Loria. Sir Buddy, are you there? Engineer Loria?
Yes, ma'am.
Okay. Is there any international institution or organization of engineers that controls or rules over unethical behaviors in research? If it's there, what are some of the penalties that might be given to the culprits? From Martin of Uganda, student at Universitas, Indonesia.
Yes. Here in the Philippines, so we have the ethics committee. We have the national ethics committee that look into the ethical part or the ethical content of research. Another is also in some of the state universities, I think they have an ethics committee. Like for example, in our school at NEUST, we have ethics committee, but I think it is only limited to social science research or research involving health and medical science. So there is an institutions or organizations that look into the ethical content or the ethical part of research. Now, in terms of penalties, of course, it depends on the investigation, and the law will be applied depending on the results of investigations, and that will be depend also on the penalties. Okay.
Yes. Thank you very much, Dr. Loria. So the next question is for Engineer Manzon. Hello, Engineer Manzon. Hello, Engineer Manzon. Engineer Rick, are you still there?
Yes, I'm here.
Yes,
Hello.
hello, sir. So this is your question. This is from Fredel De Vera. I think he's from Saudi Arabia. How can I apply Six Sigma in creating my project charter, considering the business case and business documents in selecting a project to undertake?
Okay. Actually, Six Sigma can be applied everywhere. So you have to have the complete data from your companies or from your organization, and uh, first you have to identify what you wanted to have. What is your objective? What is your main purpose of doing such event? For example, you wanted to eliminate unnecessary transactions in your offices or and so on. We have to identify the whole process. We have to identify the data and so on and so forth. If you wanted to know more about Six Sigma, we are giving free webinars on a detailed webinar on Six Sigma. Please visit us at, thank you for this promotion. That is facebook.com/iexceedph. So IEXCEEDPH. So you might have to have the whole module there So we are giving free modules there also, and webinars for this one. So for Six Sigma, actually, this is a very simple, not that simple, but let me say, most of the people, when they heard Six Sigma, it is tedious. This is too much effort, too much from our organization. But in fact, we are evaluating the whole situation on your organization or in your offices. So if you wanted to know more, so please visit it there, and we'll be trying to be as much helpful as we can, ma'am.
Thank you so much, Sir Rick Donald, for that for that information. Okay, so I will turn you over to our host for this webinar, Miss Dia Nur Hidayati, for our closing session.
Okay, thank you very much for all the presenter who give fruitful and insightful materials about transportation and also Lean Six Sigma. It gives us a new insight both for Indonesian and also Philippines, but also for other countries. So, Universitas Tunas Pembangunan open to all the university who want to have a collaboration in joining program on smart transportation and tourism architecture. We also open to all the university who want to have a research collaboration and visiting professor. Okay, and to all the participants, don't forget to fill out the form to get the certificate, to a certificate. Okay, the ICT host, please share the form. Okay, ICT host, please share the link to the screen. Okay. Okay, so you can fill out the form to get a certificate. And thank you very much for all the participants and also the speaker for today's webinar. Thank you. Terima kasih.
Thank you so much. Terima kasih.
Terima kasih.
Thank you, everyone. Okay, thank you for everyone. Thank you, Gina.
Thank you very much for everybody.
Thank you so much, sir.
Thank you so much for joining
Wish you
us. Maraming salamat.
Wish you all the best and success. And stay home and stay healthy.
Thank you.
Yeah.
Thank you, Dr. Tresna Priyana Somardi.
Thank you
so
very
much, sir. Thank you so much.
Nice to meet you, Gina. Thank you very
Yeah,
much.
nice meeting you, sir. Thank you.
Alhamdulillah. Thank you, everyone.
Terima kasih Pak Profesor Tresna kesempatannya. Kita bisa
Terima kasih. Turun sangat Pak Dr. Budi.
Yeah. Thank you, thank you. So
thank you, Mr. Yaki.
Thank you very much.
See you again next occasion.
Bye-bye.
Yeah.
Bye-bye.
See you again on the next webinar.
Yeah.
Hopefully there will be more.
Yeah,
bye. Hi, Miss Dia.
Nice
meeting you.
Miss Pia, thank you for joining.
Thank you. Thank you, sir.
I'll get back to you like next week.
Thank you, everyone. Terima
Yes, sir.
kasih.
Thank you.
Everyone.
Thank
Bye.
you, everyone.
Thank you so much.
Thank you. Sir Yafi, thank you so much.
Thank you very much, Dr. Neil. Maraming salamat.
Maraming salamat din. Hi, Ma'am Pia. Thank you. Ma'am
Thank
Gina,
you, Sir Neil.
Thank you, Sir Neil.
Gina, thank you.
Sir Alan, thank you so much.
Mr. Yaki, Miss Pia.
Sir Alan, thank you so much. Sir Alan, thank you.
All the people of UTP, thank you so much.
Thank you.
Thank you, Sir Buddy.
Mr. Alan, next time you have to be the speaker.
Engineer Eric, thank you so much.
Thank you, Ma'am President. Thank you, Sir Eric. Thank you, everyone.
Thank you.
Bye-bye.
Thank you, Ma'am Gina.
Bye-bye.
Bye.
Bye. Thank you, Mr.
Yes, Ma'am Chief.
Bye-bye.
Thank you po. Bye-bye, everyone. Thank you.
Don't have pictures.
Yeah.
Sir Yapi, we don't have pictures.
Can we have a picture taking?
Let's have pictures.
Yes, I did. I did.
If we have a picture, you send it to me.
I sent to Miss Pia. I sent it to
I'll send it to you guys.
Okay,
Yeah.
thank
Yes,
you.
thank you.
Thank you, Mr. Yafi.
Thank you. Keep safe, everyone.
Sir Yafi, see you in Indonesia
See you.
next year.
All right, next year.
See you
I
next
see you in
year.
Philippines also.
Thank you, Ramshi.
All right, thank you.
Yeah,
See you.
Bye, thank you.
Bye.
Magandang hapon.
Maraming salamat. Terima kasih.
You're welcome.
Sama-sama, terima kasih. Terima kasih Bapak Ibu telah berkenan bergabung. Thank you so much for joining us today. Selamat ini.
Selamat sore. Terima kasih.
Hanya topik. Terima kasih Ibu, terima kasih telah bergabung. Bu Eni, terima kasih ya Bu Eni.
Pak Joko, terima kasih ya Pak.
Sukses semuanya.
Pak Yapi.
Terima kasih Bu Eni.
Atas kerja.
Jatuh Salvador, thank you so much for joining us. Pak Budi, terima kasih juga. Pak Reki terima kasih Pak.
Terima kasih Mbak Yapi, Bu Diah, dan tim semua International Office.